right, we're going to take a quick look at how to solve exponential equations. You might be thinking, like, haven't we done this before? Well, yes, we did. But the ones that we did were, relatively speaking, fairly easy. Like we had stuff like this, where we said, oh, if I can just change the base, then I can set the exponents equal and everything's good. The problem is, in a lot of situations, you're not going to be able to set that base equal. So, so let's take a look at this. We're going to solve it just a little differently. So the first thing I'm going to want to do is I want to get the exponential by itself, where there's only exponential. So this 2 right here, I'm going to divide. And what I'm going to do is, there's kind of 2 ways to think of it. One of the ways of thinking about it is I can convert this to a logarithm. So I can say that I'm going to do natural log of 21 equals negative 4x plus 7. Okay, so again, this is base e. So my base is e, this is 21, and this is my exponent. Another way of thinking about it actually gets you the same answer, but another way of thinking about it is saying I'm going to take the natural log of both sides. So I get natural log of 21 and natural log of e to the something. Those are inverses, so that cancels. So I wind up with the same thing on both sides. Or I wind up with the same thing no matter which way I do it. Well, this looks scary, but it's just a number. So I can just keep going with my algebra 1. And that may seem gross, but that's something you can just shove in a calculator real quick and no big deal. Now let's look at this one. Now this one's a little trickier because it's not one of our nice bases. It's not base E, it's not base 10. Now, the good news is if you have a calculator that'll solve logarithms of different bases, that's going to actually make this a lot easier. So I'm going to do this 2 ways. The first way is going to assume that you have a calculator that can do base 4 logarithms. And then the second way is going to be assuming that you don't have access to a calculator like that, and we have to do base 10 or the natural logarithm, base e. So I'm going to start by taking the base 4 logarithm of both sides. Log base 4, log base 4. Well, when you take a logarithm of base 4 and you have an exponential that's base 4, that cancels out. You get 4 over x. This is just us hitting the undo button on that exponential. Log base 4 of 112. Okay. Again, I just did the base 4 logarithm of both sides. Now, this x is annoying because it's on the bottom, so I'm going to multiply it to both sides. Now I'm going to divide this logarithm on both sides. And if you have a calculator that can do base 4 logarithms, this is done. Okay, we've solved for x. All right, but let's say that you don't have a calculator that can handle this. Okay, I'm going to leave this right here. So there's 2 different ways that we can handle this. One is to go ahead and, instead of doing a base 4 logarithm on both sides, we can do a logarithm of a base that our calculator can handle, like, I don't know, natural log. So I'm going to do natural log on both sides. Now, on the right side, this is pretty simple. On this side, what we're going to do is we're going to use that property we learned to take this guy out. All right, now I'm going to divide. Okay. I can take the reciprocal here. Almost done. Multiply by 4. There we go. Now, this is simpler than this, but if you need your calculator to either calculate base e or base 10, then this is going to be better. Another way that we could do this is with our change of base formula. Let's see. So I'll change this to base e again. And if I rewrite this, okay, whenever you have division in your denominator, you can move that to the numerator. And we wind up with the same answer, okay? And we could have done this earlier in the problem and it would have been easier. So we can just take the base 4 logarithm, but then immediately change the base, okay? So however you want to do it, if you have a calculator that performs logarithms with other bases, it's probably easier just to go this way. If not, go the other way and it's fine. Let's do one more. All right, so on this one, if you were doing it the way where you were just trying to convert it into a logarithm, then this way is going to be really, really annoying. So that's why I recommended using the method where we take a logarithm on both sides. Now, technically we can do any base, but it's nice to do it as one of these bases because when you do it that way, one of them will cancel out. So here, since I've got base e, I'm going to do a natural log on both of them. Doing natural log on base e, that cancels. Okay, those are inverses. So I get this. Over here, it's a little more gross. Well, what can I do with this exponent? This exponent is going to pop up front. Be careful, it's this whole thing being multiplied. All right, this is the part that students find a little bit tricky. I want to get all of my x's on one side and all of my non-x's, however you want to think about that, on the other side. So I'm going to go ahead and distribute this. So 3x natural log of 81 plus 5 natural log of 81. So I get this on this side, and I move this to the other side. This just moved over here. This just moved over here. Now what I'm going to do, I'm going to factor out my x like I did earlier. Minus natural log of 81. Oops, not yet. So how do I get the x by itself? I just divide by this nasty thing right here. This cancels out. So now my x equals this quotient right here. Now, again, this looks a little gross, but that's all stuff that you can type into a calculator. As a matter of fact, if you wanted to make your algebra a little easier, you could have approximated this earlier in the problem. But if we do that, then we're dealing with these nasty decimals all the way down. So you have to ask, okay, do I want to deal with nasty decimals or do I want to deal with algebra? It's kind of up to you which is more problematic for you, okay? But either way, that is going to be our final answer. And that's how we solve exponential equations.